and welcome. Really glad that you're here, and glad that Priyanka is here to talk to us. She's the Chief Content Officer at Google, and calling from a remote location from Stanford today, the remote office. Uh, so Priyanka, without further ado, I'll stop sharing my screen. You can start sharing yours, and if I can figure out where I put my mic. I'll stop sharing. You can share yours, and welcome again.
Great. Thank you so much for having me. Am, um, I know we've been trying to make times work for quite a
Yeah.
few months, so I'm super excited to be part of it now and very excited to meet everybody. Please keep your questions coming. I think in settings like this, it's so much better to have an interactive conversation as best as we can. So um, keep your questions coming, and I'll hopefully to get to them as we go through. Apologies for any background noise because I am in a little bit of a public area here, but hopefully, if it gets too much, let me know and I'll try and switch spots. But if it is okay, we'll continue on.
So far, it sounds good.
Okay, awesome, great. So I will let's see. I'm using this platform for the first time, so we'll see how my whole screen shows up. Um, can you see the entire screen now?
Yeah, we can see it shows the main one slide, data
Okay,
science and
great.
cloud quick tour.
So what this has done is basically I don't see the interface anymore, which I guess is fine. So just Jim, just let me know if I need to pause for something or if you have a question, and I will stop talking and we'll talk about the question.
Okay. Yep. I'll monitor the chat and the Q&A chat, and uh, I'll read it out to you when they come up.
Awesome. Sounds good. Thank you so much. Okay. So, with that in mind, so today, what I had planned for this hour with us is a little bit of a quick tour on data science in cloud. And I'll warn you that this is a really big space, and 1 hour is not enough to talk about all of the different aspects of it. But but I am hoping that this hour, this content that I've prepared um, for this quick tour will give you avenues to start exploring, and then you can dive deeper into the areas that I point to as depending on what type of project you're doing or what type of project your company is doing, and or as a student, if you're working on a project for your school, like what does that require and what areas you need to focus on for that. So consider this as like a super quick tour of all the things that you might want to know about, and then as you hone in on your project, you will dive deeper into one or two or multiple aspects of this. Okay. Um, Jim did an introduction of me. A little bit more about what I do in this role is I connect with the community, like the one that we're doing today, in different ways, right? So with presentations like this, with conference presentations, but more so also online. So we have Google Cloud Tech YouTube channel. That's where I create a lot of our content. We have this entire team that focuses on understanding what people can benefit from in the adoption journey, in learning journey. So we find gaps and create content for the Google Cloud Tech YouTube channel. I also create a ton of content for social media um, for folks who want to learn faster in smaller bites, and 1 minute videos these days are sort of the thing. So so that, and then blogs, and then demos, things like that. That's kind of what my role is. And you can, if we don't get to your questions, or just in terms of like what I'm up to or what I'm working on next, in terms of content, other things, research, you can find me on Twitter as P Vergadia. You can also find with the same handle on LinkedIn. So I just wanted to throw that out there if you're interested in like following the work that I'm doing, because I do tend to share everything I do. So you'll be up to date. Okay, so the plan for today. We'll start with like a super short Google Cloud or cloud orientation, and then get into data science, data analytics, a little bit of MLOps, and then some Google Cloud tools that sort of fit into those areas of data science, analytics, and MLOps. So we'll keep it a little bit generic in the beginning, and then we dive more into like Google Cloud tools that help solve for some of those data science aspects. And then we wrap up and do some questions. So data science orientation. Now, when you're thinking about a data science project, what are the things that you don't want to have to think about? There is a reason why I kept this a little bit of a blank slide, because the list is super long, right? There are lots of things that you don't want to think about. You don't want to think about hardware provisioning, installing software, scaling things up and down as needed, paying for stuff that you don't need. Also, what if things fail? What do you do then? Managing clusters. Like the list is super long, and these are just some examples, right? You don't want to have to think about this, because all you want to do is think about just one and only thing, which is solving your problem with data that you have, right? That's what data science is all about, right? You just want to take whatever data you have and ask whatever question you're trying to answer through that data. And sorry, there was a trolley rolling by, so give it a second here. Okay, I think it's back in the background now, so we can start. So yeah, the idea of data science is like solving your problem with data. And that's the only thing you really want to care about, not all of these other things that come as a part of managing a data science system. So with that in mind, what is cloud, right? Like we go back to the basics of like, what is cloud? It really is like getting things done on somebody else's computer, especially when you really don't have to worry about maintaining, provisioning, administering, failures, things like that, because somebody else is taking care of that. And then you can just do the things that you want to do with this computer that you got on the cloud, right? That's kind of what translate that to data science. That's what you're doing with data science in cloud, which is taking all of the the list of things that we saw in red, right? Things you don't want to do, the maintenance, the provisioning, the networking, the failure management, things like that. Offload that to the cloud services, and then you can utilize the cloud to just ask questions off of the data, which is what real data science is. Right? Okay, so how do we do it, right? We do it in sort of 6 steps. Now, if you ask different people, you're going to get different number of steps. It doesn't matter. What matters is really how do you structure it, right? Like, so in this case, this is just my understanding. There is data engineering. You need to collect data from somewhere, and then start preparing it, storing it, so that your downstream systems can use it. Then you analyze that data. That's the second step. Then you create a model, using, again, like you might not be creating models, you're only maybe analyzing, right? So that's why I said, like, it's not really a 6-step process. It's like these are the steps in any data science project. And now there might be things that you're not doing in a specific project. For example, you may not be creating a machine learning model, or deploying a machine learning model. So those 2 steps would go away, right? And you're only analyzing the data that you've got. So but if you're doing model development and model ML engineering, then those 2 steps exist in your process. Those will be the third and the fourth step. And then you take the insights from your models, and then you influence the business with like reports or charts or dashboards, and or just taking the data and equipping your applications with that, with the predictions of your model. And then the last piece, which is the number 6 that I say, is orchestration, which is you will have to make sure that this is a pipeline that's for a production system. It can't be disjointed. It's like all the things that you're learning through the model have to also be fed. Like the model has to have continuous training with new data, with things that it's learning from the world. So how do you keep this model going with data pipeline, ML pipelines, scheduling of data to move from one place to another, scheduling cleanups of the data, things like that come under orchestration, and then monitoring the entire thing. So those are roughly those 6 steps. Now you could combine the ML steps into one. You could have data engineering and analysis into one. It sort of depends on who you're talking to and what project they are doing. Sometimes you also see that there are teams that are working on there are big teams that have job functions that are aligned with these. And then there are smaller teams where only 2 people are doing all of these tasks, right? So it sort of depends the maturity of the team, the maturity of the projects, and all of that in order to define these very explicitly for where you sit. But in overall, this is kind of how the steps sort of look like. Okay, so I don't expect you to grasp this in any way, but I'll throw this here just for you to see that I've tried to do with the sketches, map some of our Google Cloud products with these steps and how they help you in each of these steps. Like a data ingestion, where it's like these are some of the tools that help you ingest data into Google Cloud. These are some of the tools that help you process data. So I'll have you look through this. This is also available on cloudguild.dev in other places, or you can take a screenshot here too. But I don't plan on going through this whole thing, but I think it'll be helpful for you if you're in the Google Cloud ecosystem to sort of look through this and see what services fit into each of those buckets. Okay. Data analysis. So the first piece of that puzzle out of the 6 that we talked about was data analysis. In data analysis is again, like if you deep dive into data analysis, it's sort of these 5 steps, right? You capture the data. Before you can analyze anything, you sort of have to have the data somewhere. And because normally in an enterprise, the data is in different places. So the first task becomes how do we combine that data, bring it into one place, or some way of doing that. So you capture the data, you ingest it, depending on where it is. There could be batch files, then you get it in cloud storage. It could be somewhere in your data center, then you get it through data transfer appliance, which I'm not showing here. I think, yeah, I'm not showing that here. But if you have large amount of data that's just needs to be moved from data center into Google Cloud, then you do use an appliance. Or if it's streaming data, like you're taking an IoT device that's sending some data every time an X thing is happening, then you stream that data in. So we combine all of this data into one place, and then you process that data. The processing step is, like, for those who don't know what processing is, it's really basically preparing the data for the next stages of analysis. So sometimes it could be, okay, I don't need this column, change the dates to this, or remove all these commas. So just whatever, those are just simple examples, but imagine, or sometimes combining 2 columns to create a third column that does Y or is influenced by the data of the 2 columns. Stuff like that is what processing entails. And there are multiple options for doing that, especially in Google Cloud. Like if you are a team that doesn't have expertise in writing code or need a visual tool, then there is data prep, but also a new tool, which the sketch is a little old. The new tool, which is Data Fusion, would allow you to do a point and click of like cleaning up data. And then if you're using Spark or Hadoop, which is the open source system, then you can use Data Proc, which allows you to spin up the Hadoop clusters in literally 90 seconds. So for those of you who have spun up Hadoop clusters, you probably know it cannot be done in 90 seconds if you're doing it on your own in a data center somewhere, or just even in cloud on your own, right? So data proc is sort of that. It goes in back to like my first slide, right, where we were talking about why cloud for Google for creating data science projects, right? That this is the reason, right? So you don't want to spend too much time in creating that Hadoop cluster, but you want to use the Hadoop cluster to run your processing, right? That's what this is. The data proc would help you do. It'll spin up the cluster in 90 seconds. It'll grab the HDFS files from cloud storage. You'll provide where the files are in cloud storage, and then you are on your way to start processing. Data flow is sort of similar. It's based on Apache Beam, and it helps you stream and batch process data at the same time. So you can get the stream and batch processing data. You can even use data flow to sort of ingest and capture data too. But I didn't put it in the previous step because it's more apt for the role that it does is processing. So once you have processed, now you're ready to store it. You want to store it in a data lake, such as cloud storage, where all the data is put in, structured, unstructured. And then BigQuery is sort of where it's a data warehousing, serverless data warehousing platform, where you're putting all this data, and then now using SQL, you can start querying this data to do the analysis. So that's sort of that overall pipeline of like, how do you do data analysis? That's why this whole thing is like machine learning and data analysis is not just machine learning and analysis. It's like all these other steps that you need to capture, process, store the data in one place so that you can do the thing you want it to do, which is analysis and doing machine learning. Now that last step is using, so you can do machine learning on the data that's in BigQuery. Now you can also do reports, charts, dashboards, things like that, and then utilize that. The things at the bottom are really the orchestration pieces. How do you make sure that the data moves from one step to another? How do you keep track of that? How do you search for the metadata so that it's so that you can search for all the data that's in your system? Things like that. So I'm not going too much into the orchestration pieces right now, but that's your data analysis piece. That's the first step that we were talking about that includes engineering and analysis. Now we jump fast forward into MLOps. We have, I'm sure you have, if you have already tried to build a machine learning model, then you probably know this by now, that launching a machine learning model is super easy, but operating is extremely hard. And I think this is true for any application as well. So when application development was super new, like, okay, I can launch an application, but how do I actually operate it, right? Like the whole CI/CD behind it, all of those other things are super critical to have a successful production ready launch of your applications. It kind of applies to the machine learning models too. The real problem with ML systems will be found while you continuously operate them long term, right? Because imagine this: like your machine learning model is trained on the data that you collected today, past from the past and up until today. What happens tomorrow? Once you have launched this model, the data continues to evolve anyway, even though your model is not informed of that data. So that's what makes it this really hard, right? You have to continuously learn from the new data, train the continuously train the model for newer data, and then keep deploying it, and that cycle has to continue always. Now, developing the model is really just the beginning. Like I said, model code is probably the easiest thing you will do in machine learning. The easiest thing you will write in machine learning. If you see the bigger picture, a machine learning product requires a lot more, right? And you can see these boxes in perspective of ML code that we were seeing in the previous slide. Now it's become shrunk to just that tiny little piece. The configuration, collection of that data, feature engineering, analysis, monitoring, continuous monitoring, all of that data validation is are such big pieces of a machine learning project that ML code is, like I said, the easiest thing you would probably do in a machine learning project, which is why it's easy to launch but hard to manage as a product. Why do things become harder in production? Well, these are some of the examples, obviously not a complete list. Cleaning is hard, data cleaning is hard, processing is hard, scaling your infrastructure to deploy the machine learning model, it's hard. You would run into infrastructure issues, tracking, monitoring, reproducing those requirements, especially the model and data drift, the stuff that I talked about around you've trained your model on specific set of data, and the data continues to evolve and change. So how do you manage the drift and the skew of model over time? And then access controls and then security requirements as well. There's a lot more that is not even here. So those are the challenges. Now, the level of automation really defines that ML process. So once you have, these are broadly the levels, right? Level 0 is you've built and deployed a manual machine learning model. Great, that's the easiest thing to do. Once you've automated that training phase, that's your level 1 of automation, right? Maturity of your machine learning process. Now, level 2 is you've automated the training, validation, and deployment. That's where you've got this whole cycle of like, you've trained the model, now you know how to validate it, you also know how to do continuous monitoring, and you know how to deploy it. And then that whole thing can happen over and over. And that's sort of, in short, what MLOps is. All the stuff that I'm talking about around MLOps is from this amazing paper, Production ML Experience. And so I just wanted to put a screenshot here. If you're interested in reading the entire paper, it's an amazing read. If you want to learn more about how the whole MLOps is perceived and done, especially have been done for a long time within Google. Cool. Okay, so this is also a quote from the paper that I just mentioned. On any given day, there are thousands of TFX pipelines, which is TensorFlow Extended, is sort of the MLOps version, name of the TensorFlow Extended pipelines running, which are processing exabytes of data and producing tens of thousands of models, which in turn are performing hundreds of millions of inferences per second. So that's the scale that we're talking about that Google has been operating on. And then you can read how it's done in that paper. And those are some of the learnings from the paper that I have had on the slides of, like, literally the 5% of the work is creating ML models, and then rest 95% is all the other boxes. All of that is from that paper. Okay, so now we get a little bit into Google Cloud world. So this, I always say this, you don't have to create a machine learning model unless you really, really have to. So this is what I mean by that. This flowchart sort of breaks it down. You don't start by creating, just like having a problem and creating a machine learning model. The first thing you do is, does somebody else have a model that I can use, right? Because like you saw, it's really hard to maintain a model and to keep it fresh and stuff like that. So the best thing you can do is, if you have a problem that you're trying to solve with machine learning, see if somebody else has a model or a solution that has already been built on a model. So this is where, okay, so now if we start from the very left of this slide, does your use case fit a prepackaged AI solution? When you're looking into Google Cloud specifically, there are some prepackaged solutions like recommendation AI. There's stuff in retail, document AI, which helps you read through documents and scan using OCR, like scan the documents and then create a JSON that you can use to in any other ways, right? Because now you have structured data. Contact center AI, which powers contact centers and helps create chatbots and voice bots using NLP. We've already solved for those very common generic use cases. So if you have a use case that sort of fits into those categories, don't just build a model. Try and use what already exists, because it's easy for you to build a model, but it's hard to maintain it. So that's how I would approach a machine learning MLAI project. These choices also depend on how mature the team is, right? How mature the people who are working on these projects are in machine learning and AI. So for example, here, if you're using, you would gravitate more towards prepackaged AI solution if you have a team that's not very advanced in ML and AI as well. That's another factor to consider, because it is sort of a no code, low code sort of option. So, oops, think about that, as well as just adding complexity. If you don't want to add complexity if you don't have to. So those are the two things. Now, once you're like, okay, the prepackaged AI solutions are something that don't really solve my use case, then you get into, do you have your own training data? If you don't, then think about all the common unstructured data problems, like looking into images and finding things in the images, looking into videos and finding things in the videos, translating one language to another, understanding sentiments in text, shortening the text, speech to text, text to speech. Those are very common use cases that Google has already solved for with large amounts of data that we've seen so far. And these models are pre-trained, built on those data sets. So now you can basically, if you have a use case that's in that category, and a lot of things fall into this category, right? You've got, maybe you have a system where people upload images. You want to make sure that there's no PII in these images. All you have to do is use Vision AI, Vision API, do an OCR scan, maybe see if there's any PII information, people's names and things on the images, redact that out maybe, or just remove the image altogether because it doesn't fit your criteria. And then that's your answer, right? Your system might have comments, and you want to scan through all the comments and remove the ones that are bad, or use foul language, things like that. And that can easily be done through natural language AI. It's already trained for stuff like that. So think of use case. If you have use cases that are along those lines, you're set with just using pre-trained APIs. Now, if you have your own data, obviously you want to train those models on your own data, in which case, look at BigQuery, right? If BigQuery is, like I said, I'll talk a little bit more about BigQuery in a few minutes here. But BigQuery is data warehouse, but it also is, if your team is comfortable with SQL, it also offers machine learning just by using SQL commands. So it's like you can select a set of tables and start creating models just using SQL. So again, it also boils down to the expertise of the team. If the team is the analysts and data analysts and data scientists are expert with SQL on your team, then BigQuery ML might be the first choice I would go for, right? Because they don't have to learn something new. They know already how to use SQL and the data is already in there. So use BigQuery ML. Now, for something like, I still want to have no code, low code option. I have the images that I need to, or the data that I need to do to create the model. Then we have AutoML in Vertex AI, which is you're building your own model, but sort of in a no-code fashion. So you upload your data and we build the model. So the platform would build the model for you. You can see how the model's performing and then use that model. This is again a great way for picking um, picking a solution that's more inclined towards folks who have less expertise maybe in creating machine learning projects or code, but at the same time have something created quickly. And so it's like a balance of the expertise as well as how much time you've got and what type of team it is and what type of project it is. So if the project fits the AutoML version of it, I don't want to create my own training code. And then we come into the very last, the thing in the red, right? To write your own ML code. If you've exhausted all these options for your use case and you're like, you know what, none of that works for me, I do really need to create my own machine learning code and then deploy my ML model and then have it serve for the applications. Sorry, I am being asked to sort of move for a slide a second.
Okay.
Thank you. Can I still use the space though? Thank you so much. Thank you. Okay, sorry for the interruption there. I am back. Cool. Okay, so you guys can still hear me?
Yep. Sounds good.
Perfect. Okay. Um, so that's like if I've exhausted all of those options, that's when I would go start building my own code. And I I say this with like there is a lot that you could be spending your time on. You really choose to get to this route if you have to, right? So let's say you have to build your own code, you have to write your own model. Perfect. Use Vertex training for that. Create your own code. You've whatever framework you use, TensorFlow, um, scikit-learn. We support quite a few of the major ones, and build your model that way. and and that's sort of my recommendation on how you should pick your AI ML path. Now, if you're using another cloud, sort of apply the same thing, right? Like this, I think this applies everywhere. Okay, now diving a little bit into Google specific BigQuery and BQML. Now, BigQuery, I keep talking about it. It is a data warehouse um, with really high scale, right? It scales really big. You can think about things like, and the biggest part, it supports SQL. So, and from security perspective, it supports encryption for data that is in there, and this is the scale that I'm talking about. So if you run this query, so if you think about this query, this is a regular expression on a Wikipedia data set um, between for 4 years, and between 4 years, and we're just running any query for coronavirus. And you can see it processed 2 terabytes of data in 21 seconds. That's huge. Like if you were doing this in any other like hosted, like all you creating the infrastructure to run that query, that's a waste of time, right? Like and you still wouldn't be able to get to this fast speed. And that's the power of using cloud services to do data analysis. I think for data specifically, it makes sense to utilize cloud services because you really don't want to spend time in infrastructure building and imagine the type of infrastructure it would take to run this query. And you'd be just spending time doing that. That's the box there. 3K cores and 1K disks is what it took to run that query in 15-20 seconds. And what BigQuery did is in the background, it created all of these because it already has these resources, right? So just for this query, it provisioned these resources and ran that query and gave the results. You can't imagine to do that on on an on-premise environment or an environment that you build yourself. So you can focus more on doing the actual thing related to data science. And then this leads me into the BigQuery ML piece, which is you can train and deploy your machine learning models just using BigQuery with the SQL statements. So here, like you're seeing predictions happening, and then you can see those predicted things in the same interface as well. And I want to get back into the just for one more time, yeah, the model creation. So you write create model. Here are your options from this table, and your model is created, and then you predict using the predict command for that model, and you have the predictions. And you have lots of different model types that you can utilize. So if you're doing classification, regression, um, model ops and explainability and other things, like there's lots of different models that we are supporting and are continuing to build towards so that people can just use SQL to write models. So if this fits the use case, go this route, right? Like I was saying in the flowchart. Then the last thing, which is Vertex AI, it's the managed ML platform to speed the rate of your experimentation and then accelerate your deployment of the model. So it kind of goes end to end. So this is sort of that flow, right? You have the data set, you have the feature stores, you create the feature store, and Vertex AI lets you do that. We have a feature store, and then you have a workbench, which is the notebook, which hosted notebook where people in the team can collaborate on. So you're basically writing. So if you're familiar with Jupyter notebooks, Workbench is sort of the hosted Jupyter notebook, which Git, you can write your own notebook, but then it's also you can create versions on Git so that the other team member can utilize the same things that you're doing, and you're not repeating the work, especially in the data science world. Like if somebody's already done X and you want to utilize that X data, then workbenches are perfect for that, right? And then from there, you experiment, you track results, train your model, scale it, create the endpoint. Endpoint is basically you're deploying the model so that your applications and other things can use that model. And then in your deployment phase, you don't have to worry about how is it going to scale. If it's 5 users or 5 million users, Vertex AI sort of takes care of creating serverless infrastructure to serve those requests, and then it scales it back down if the request traffic goes to minimum. Same thing it does in training as well. How do you if it's large amount of data, we scale the amount of compute resources that are required for training, and then obviously the resources go away once the training is done, and then we continue to monitor. There are features to monitor the pipeline as well, and then this whole thing sort of becomes the feedback loop. That's the end-to-end ML journey that Vertex AI sort of helps you solve for, provides you tools to solve for. Okay, with that, I pulled through resources from a bunch of different places, and these are some of the things that you could go read more about. If you want to take a screenshot, please do. This and the paper. If you just search for MLOps paper by Google, you'll probably get the first link as that paper that I was talking about. If you're interested in that, I didn't put a link for that one here, so that, and then a few more resources. If you're interested, you can take a screenshot of this as well. This is more of a use case type thing with BigQuery ML specifically. If you're interested in that, you can look at those use cases at Google/BQML use cases, and you can try some of these as well. More generically speaking, I manage Google Cloud for Words. So if you're interested in learning just the breadth of Google Cloud in general, I do more abstracted higher level stuff around which tools you use for what sort of thing across Google Cloud. I think that's a great place to learn if you're super new to Google Cloud. So I'll leave you with that. And that's how you can reach me.
All right. The white paper that you were showing, I did post a link into the chat. So if you are a white paper person, go ahead and you can read it. And that's yeah, that's I haven't read it yet, but uh, typically the Google white papers are quite nice. And if it has some warnings for those people that are going into an ML journey to think about the ops side, which even on developing regular software, a website, a lot of times the ops stuff gets forgotten, uh, and ML sounds like it's a similar, if maybe even a more complicated thing to keep the beast up and rolling once you have it.
I think
Um,
so.
yeah,
One
go ahead.
one point I would add there is like you're right. Like it's even more complicated, mainly because it's it's like you have to treat it as an application. You're using Kubernetes, like you're learning all these things that are not machine learning, basically.
Hmm. Hmm.
Right, in order
Yeah.
to deploy and scale it. But you have expertise in machine learning, so it's like
Yep.
you're having to learn all of the application related things and how do you deploy an application, things like that. So Vertex AI sort of takes takes away that complexity, because now you don't have to think about a container to deploy your model
Hmm.
in or to train your model in. So I think, yeah, it's like if you were doing it yourself, it's like if you're familiar with Kubeflow and stuff, like you know that you're building a container to deploy things. But this is sort of trying to make it easier, to not have to like it. Containers are still there, but they're in the background now
Hmm.
instead of
Hmm.
you thinking about containers.
Yeah, which is helpful. I will get the presentation from you. I'll post it to the event page, and if it's just a open, I see it on Google Docs. If it's even something that can be shared, but I'll grab it from you, and I'll make sure to post it on the event page. Uh, so we have a question from Jay. He's a colleague of mine who does some creations of his own. He's wondering who does the illustrations for Cloud Girl. Hope you to mute.
Okay,
Not
do you
sure
mean
how.
the sketches that I was just showing, or the
Yeah, the
illustration
sketch.
for the superhero Cloud Girl?
Oh, let's go with both. Let's start with the ones that you're
Oh,
showing,
the superhero one. Oh, actually,
oh,
okay.
and then he's interested in the superhero because he does Jay does get into superhero sketches.
Oh, awesome. Okay. Um, I would love to connect with you, Jake, because I keep coming up with crazy ideas, and I always need illustration help. The superhero part of it, actually, I am a big fan of Canva. Anybody who doesn't know Canva is like this amazing tool where you don't have to be a designer or an illustrator, but you can use all the pre-made things that they have available. So the superhero girl is from Cloud Girl is from there. So I sort of combined
Hmm,
a few pieces of different things in there to make that. So I haven't really created it, but I sort of designed it with different things.
okay.
And
Oh, that's cool.
yeah, the illustrations themselves, um, did them in Adobe Illustrator initially, but I couldn't scale myself. So we got help from another illustrator that helped me scale me, because otherwise these wouldn't be possible.
Yeah, not quite as scalable as the
No,
BigQuery backend.
nope, that's just me.
Uh, and then Jay has another question. Keep them coming. Uh, how do you see cloud computing solve problems for the metaverse? Any thoughts on that?
Oh my God, that's a hard one. Okay, so I was reading the other one from Ramji. No, so I personally think all these innovations that are happening in the space, not just metaverse, but I recently watched a video. If you haven't seen it, you should totally see it. This is like a 3D version of Google Meet. It's called Starlink, Starline, Starline, I think. So if you just search for, let me search it right now though, just so I Starline Google. Yeah. So if you search for that, the first thing that shows up, definitely watch it. Like it's like I'm talking to a person who sort of is right here. It's like in three dimensional. So all these innovations, just I personally feel that cloud is where they're all going to be powered from, right? So cloud sort of plays this huge role in building or being the infrastructure for building these applications, because where else would you deploy them, where else would you do the processing for the more real or the metaverse or things like Starline. That blew my mind. Kind of scary as well. It's the Starline stuff. Just like, oh, this person seems like they're right here, but they're not. So anyway, I think that's my take on it.
Right. Looking into the Q&A chat, I don't see any questions in the Q&A chat. If there are some, there might be on my side. But if there's any, if you do have something in the Q&A chat, I guess if you copy and paste it to the regular chat. I haven't seen this problem before, but you never know with technology. Things happen. All right. This one's from Xiaodong Mei. How how would you compare? So on the set of products that we're looking at today, the data and analytics, and I guess even on a broader scale, do you have a handle on Azure's product set and uh, how
You
they would
know,
compare?
unfortunately, um, I don't have a very good handle on Azure space. So sorry, but I will find maybe a link or two for that.
Yeah, that's
Yeah.
fine. It's I think it's probably full time keeping track of all the changes
It's so
that are
hard.
happening on
Yeah.
the Google side, let alone the Azure or Amazon or
But I do know that
does
all the
Tencent
clouds
Cloud have AIML? I'm not sure.
I
Oh, go ahead.
do know that all the clouds have, like the decision tree that I was showing for machine learning, for example, like
Yep.
all the clouds have those capabilities in some way, shape, or form. I
Mhm.
I know that for sure. Now, how the backend works, like for example, how BigQuery works in the backend, there's no comparison to that in the other clouds, right? Because it
Mhm.
is that um, Google has seen these problems before they were problems for anybody, right? Because the
Mhm.
scale at which Google was operating, we deploy so many containers since so many years ago, right?
Mhm. Mhm.
And the data problem was huge for Google, indexing all this data just for search, right? And then Android and Maps and all of these things had already shown the things to tackle were already seen by Google. So
Mhm.
Bigtable, BigQuery, Spanner, Bigtable, these are products that have come into existence because they were being already used by Google internally. And then they were like, okay, these are great things that can be utilized by other companies as well, which is kind of how Google Cloud was born, but also some of these products are born. So I think the difference is in the underlying infrastructure. When
Mhm.
you peel the layers, that's where you find the difference. Capabilities wise, I think all the clouds in some ways sort of provide all of these solutions. It just depends on when you start to drill deeper, that's where you find the differences.
Mhm. In each category, you'll find similar products, but the backends, who knows how scalable they are or what it's actually doing, and then maybe each cloud has a slightly different at the API layer of like Vision API or something like that. They might be slightly different offerings
Yeah,
at that high level
yeah,
of pre.
that's my understanding. And I think I'm totally saying your name wrong. May Zai. I'm just
Yeah,
gonna go with
yeah.
Zai, right?
It's
Um, yeah, they mentioned Azure do have almost everything, right? So
yeah,
yeah,
yeah.
exactly. Like all clouds have all the capabilities. I think at this point, it's just on the infrastructure side of things and what's working best for you, which is also why I think, which we didn't talk about here, is there is the huge scope, and the next applications are going to be all multi-cloud, right? Because you have some things there, some things here. You're using different clouds for different for solving different problems, and then you're bringing, like, BigQuery now also supports bringing in data from other clouds
Hmm.
to just run query, and then the data can sit wherever it is. So it's sort of thank you. So it's sort of, I think, is like leading into the whole that the future of cloud is going to be multi-cloud.
There's a somewhat long answer question. I don't know if it's a question. It looks like it might be a Ramji question. At least he pasted it there. If it was from the Q&A. Uh, uh, but it's ML model building is easy, simpler than BQML for a citizen data scientist. There's a problem though. Prediction is not very good. Are there any recommendations on steps to see how to get to production ready models quicker? Uh, some kind of
Yeah,
follow-up
okay.
questions after that.
I'm able to see these as well, so we
Yep.
can take them one by one. Okay. So great feedback. Thank you for the BigQuery ML simpler use cases models. If you're not seeing very good performance, definitely something I need to take back to the team as well. But um, I say this all the time, and this might be a non-answer for the question, but I would still say it. If if that is like, I think model building is also always an experimentation, right? You're tweaking the features, you're tweaking what features take more priority, and all of that. So if say BigQuery ML model is not giving you good prediction, um, did you try the Auto ML version? How did that go? And then there you can tweak features and stuff as well, and then like AutoML tables, for example, explicitly. There you can tweak the features and then see how that did. That's another way of sort of being in that experimentation phase of like, what model's working for me, how much do I need to tweak my features to get there. So I think AutoML is probably something that I would try as well, and then if it doesn't work as well, because AutoML sort of picks the underlying model for you too. If that doesn't work as well, then you can see if you want to build your own model, and be- because there you have a little more control over hyperparameter tuning, things like that, right? Which you don't have in Vertex AutoML model. So that's the route that I would try and see. But I definitely hear you. I've taken feedback. We'll relay it back to the team on the BigQuery ML prediction side of things. Okay. The other question was, are there specific models that work for certain generic use cases? Oh, I think I had a slide there that, especially for the BigQuery ML one, I had a slide there for something like this, where if you're doing classification, regression, then these are the model types. You can find these on BigQuery ML documentation page as well. But if you're not talking about BigQuery ML, that's fine. If you go into Vertex AI, you'll be able to see the different model types based on classification, regression, and other model types for Vertex AI as well. Cool. And the other one
Right.
is, I know we're up on time. Sorry, that's probably what you're saying.
Oh no, I was just I thought it was the end of the questions from Ramji, but if
No,
there's
I
one
think
more,
there's
yeah,
one
go for
more.
it.
Are there tools that make it easy to monitor model performance? Yes, that's why I mentioned Vertex AI. Model performance, you can monitor model performance in Vertex AI. So if you're building the model through that, you could do that through Vertex AI. So check that out. I also have some videos on Vertex AI, which kind of they go through all of these steps of like building the model, creating it with AutoML or with just code on your own. How do you monitor it? So if you haven't checked that out, I think we've called the series Simplify AI, and it's on Google Cloud Tech YouTube channel. So check that out if you are not aware of Vertex AI features.
All right. I do have one question that's non-technical that I ask all of our speakers. It's kind of a career help type of a question, and it's if you could go back in time and say talk to 20-year-old Priyanka, any kind of tips that you would career tips that you would give to her?
Um, I'm glad you asked this question. I think um, just taking risks, taking more and more risks, is one of the things that and it's not that I didn't do it. It's just that I think that I've seen so many benefits of taking risks that
Hmm.
um, that I want to scream and tell everybody that this is really important to grow a career, especially in tech, because the world in tech evolves so quickly that if you are not on your toes, taking risks, trying things that you love, and then being okay with like things that didn't work out. I'm always okay with things that don't work out because I'm satisfied that I tried.
Hmm.
And this has happened with specific tech that might be coming. This has happened with even trying different roles in my life. So
Hmm.
I was a software engineer right out of school. Then I moved into being a sales engineer. I absolutely loved being interacting with the marketing teams, with the sales teams, with being that technical resource for folks on the front line.
Hmm.
And then from there, I kept enjoying that. So I kept doing it for a few different companies, but kept changing the tech that I was working on.
Hmm.
And that's kind of what led me into the core like infrastructure from cloud perspective. And then I started enjoying talking about some of these things that I've become an expert in wider spaces like YouTube and broadcast things and conferences. So I moved into this other role called developer relations now. So, but none of that was possible if I didn't take these little risks in the middle to try different things. Like I didn't move into developer relations. Um, I tried it for as a 20% project for six
Hmm.
months. The deconstructing chatbots, for those who've seen that video series that I've done, that was my 20% project, and I was in love with what I was doing. And I was like, okay, how do I make this my full-time thing, right?
Hmm.
These are little risks. Like that is the example of a risk that worked. Another example was the switch from being a core software engineer uh, to becoming a sales engineer. Super huge risk, compensation change, all sorts of things change, right?
Hmm.
But yeah, that's one thing I feel like I think we give very less time and energy um, to these soft things that play a huge role in making a career. And that's the advice I would give to my younger self as well, because it has worked for me.
No, that's good. Yeah, taking those small risks, maybe moving into an area that you're not expert in. See if you like it, and if it's a failure, you try it. If it works out, then that's maybe a place to push into even more. That's no, that's
Yeah,
great.
even the social media side of things, like people who do follow me, I I do stuff for a week, for a month maybe, and I learn a new thing and I learn it in public. And then I'm like, you know what? Not working out, not doing this anymore, changing topic or doing something else for a
Hmm.
few
Hmm.
days and then coming back to it. So you just find things you love. If you don't explore, there's no way of finding, right? So I feel like that's that's kind of what I go by. It just helps me stay excited.
No, that's great. All right. Yeah, looking at the Q&A chat and the chats, I think we've come to the end of the questions. Uh, I think your mic went on mute again. You might have done on purpose. I really appreciate you taking your time to come present to us. I'll connect you up with Jay later in case you need some illustration help. He's really great. And yeah, thanks again. Glad you could come. And uh, I don't want to clap into the microphone. Yeah, the quiet clap, the quiet clap.
Thank you so much for having me. It was so much fun. And thank you so much for all the attendees for attending and hearing me ramble for an hour.